I would like to share you the agenda of the entire session series. That is, we will be covering up topics from mechanics, heat, optics, sound, and electricity and magnetism. So these are the topics which we have designed to cover up, wherein we will be covering up majority of the fundamentals dealing with these kind of topics, and also we will be simplifying few of the problems based on these contents part. So today, since it is day one, we will be covering up with the mechanics portion, and rest of the topics will be covered up in the next session itself. So let's get started with the today's topic of discussion part, that is the mechanics portion, wherein four chapters of mechanics, that is laws of motion, work, power and energy, laws of gravitation, and fluid pressure and capillarity will be covered up. So starting off with the introductory part of laws of motion, that is the inertia. Now we already know this thing, students, pretty well, that inertia is the property of any of the object by virtue of which it cannot change its state of rest or state of motion along a straight line on its own. Okay, so if we observe that the greater is the mass of any of the body, the greater is the inertia, and vice versa to it. If the mass is lesser, the inertia is lesser. Okay, we have observed three different types of inertia in our entire study part, that is inertia of rest, inertia of motion, and inertia of direction. So I will not be covering up the detailed study at present, but we can have a few recap of it because we also need to finish it off with the other topic. So what I will do is the prime part I will be discussing it, whatever the contents I would share it with you, and the parts which are already displayed properly and that can be readily understood, that I will be simply dictating the key steps, that is, as I've discussed in this inertia case, that is inertia of rest, motion, and inertia of direction. So these are the things which will be observing it. Apart from it, inertia, we also notice the prime part of laws of motion, that is the force. Now, as and when the force discussion is to be considered, we already know this thing pretty well, that force is a push or pull which changes or tries to change the state of rest or state of uniform motion, size or shape of a body. Now we already know this thing, that SI unit is Newton for force, and the dimensional formula, that is M1 L1 T raised to minus 2. Now in the MCQ part, these kind of questions can be asked to you, that what is the dimension formula for force. So this thing you need to keep in mind, that it is M1 L1 T minus 2, where MLT are mass, length and time respectively. Now when it comes to the study of force, we have observed two different categories of force, that is contact force and distant forces or field forces. So contact forces includes the frictional force, tensional force, spring force, normal force, etc., wherein two bodies are in contact and they experience a force on coming into the contact. And distant force, that is the field force, are observed generally in the case of electrostatic force, gravitational force, magnetic force, etc., wherein the physical contact is not necessary. Now then after we have studied the impulsive force. So what is impulsive force? A force which acts on a body for a short interval of time and it produces a large change in momentum. Now can anybody tell me what is momentum? You can have your answer in the chat window if you want to. You can also use the abbreviation. Momentum is denoted by P. So what is P equals? You can have your answers in the chat window. I'm writing it over here. P equals blank. Very good, very good. And yes, I'm finding the answer. Yes, the product of mass and velocity. Okay, so P equal to mv. So ultimately, impulsive force is a force which acts on a body for a short interval of time and produces a large change in momentum. That is generally known as impulsive force. Now, whenever it comes to linear momentum, so the fundamental states that the total amount of motion present in a body is called its momentum, whereas linear momentum of a body is equal to the product of its mass and velocity, as you have already mentioned in the chat. Now, SI unit is very easy to identify. The unit of mass is kilograms and the unit of velocity is meter per second. So the SI unit turns out to be kg meter per second, and the dimensional formula is m1 l1 t raised to minus 1. See over here, no exponential values are mentioned, so it indicates that mass is having the exponent as 1. Similarly, length has exponent 1 and t time period as exponent minus 1. And momentum is a vector quantity. Why? Because we have velocity over here. So velocity is a vector quantity. We already know this thing. So ultimately, mass is a scalar, velocity is vector. So the product is scalar and vector product will ultimately give you a vector. So momentum is a vector quantity and its direction is in the direction of velocity of the body. So this is the fundamental for linear momentum. Now, when it comes to law of conservation of linear momentum, so it states that if no external force acts on a system, then its total linear momentum remains conserved. Ultimately, what happens, this law of conservation of momentum, we are utilizing it generally with the help of equation as P1 is equal to, just a minute, let me erase this part. We are writing it as M1 V1 is equal to M2 V2, wherein V1 and V2 are velocity vectors. So we generally equate it in the numericals and we find out the answers pertaining to it. Okay. So linear momentum is a quantity which depends on the frame of reference, but law of conservation of linear momentum is independent from the frame of reference. So this is a part which we need to know this thing as a part of MCQ. Okay, so linear momentum depends on the frame of reference, whereas the law of conservation of linear momentum is independent of the frame of reference. Now, Newton's laws of motion are valid only in inertial frame of reference. Okay, so if frame of reference is not defined, we cannot apply the Newton's laws of motion. Thereafter, we come across the terminology that is impulse. Now, the product of impulsive force and time for which it acts is called as the impulse. So impulse is equal to force into time, that is also equal to change in momentum. Now, this impulse can be readily observed by a cricket player, wherein let's say if a fielder is catching the ball which is coming from the height, so what he generally try to hold the ball in such a way that, let's say he raises his hand. I'm drawing a stick figure over here for the sake of simplicity. He raises his hand over here, so the ball comes down just like this way, and then as soon as the ball touches the hand, he lowers his hand to the back direction. So ultimately what happens is the impulse is getting reduced and he is not getting hurt in his hand. Okay, otherwise if the ball is coming from height with a certain velocity, he may get hurt in the hand and his hand can get fractured sometimes. Okay, so to avoid this, he uses the fundamental of impulse. So the impulse, that is ultimately the product of force and time, and its SI unit is Newton second or kg meter per second, which is having the dimensional formula as m1 l1 t raised to minus 1. Now the impulse is also equal to change in momentum of the object, and it is also a vector quantity. Why? How we can come to know that it is a vector quantity? Because impulse is product of force and time. Now force is a vector quantity, we know this thing. So, and time is scalar. So when we take the product of scalar and vector, it results into vector. So ultimately impulse is a vector quantity and its direction is in the direction of force. Now it is important to note over here that total impulse for the force applied during the time period t1 to t2 is equal to area under the force time curve from t1 to t2. Now we come to the prime part of our of our laws of motion, that is Newton's law of first law of motion. Now a body continues to be in its state of rest or state of uniform motion along a straight line unless an external force is applied on it. This law is also called as law of inertia. We know this thing pretty well, that the inertia, law of inertia, or the Newton's first law of motion, it is how it is well defined that if a body continues to be in state of rest or it continues to be in state of uniform motion along a straight line unless and until an unbalanced force acts on it. Three examples are given over here, that is when a carpet or a blanket is beaten with a stick, then the dust particles separate out from it And also, if a moving vehicle suddenly stops, then the passengers inside the vehicle bend outward. Or if a stop vehicle starts moving at that point of time, also this fundamental or this law can be readily observed. The next part, which is the Newton's second law of motion, that states that the rate of change of linear momentum is proportional to the applied force, and change in momentum takes place in the direction of applied force. Now, mathematically, if I want to put down this law, it can be written as force is directly proportional to the rate of change of momentum, which is given as dp by dt, and which can, if I want to remove this constant of proportionality sign, I need to introduce a certain constant value, so that is equal to k d by dt of mv. Now this p is written as mv over here, v is a vector over here, which is denoted by a bold v, where k is a constant of proportionality and its value is 1 over here for the sake of simplicity, and in SI and CGS system. Now force, ultimately, if you we know the property of derivation, that once you are derivating a certain quantity with respect to certain given entity, at that point of time the constants are to be taken outside the derivation. So for that we take m outside the derivation, and ultimately dv m, it turns out to be m dv by dt. So dv by dt is ultimately the acceleration, so force is equal to mass times acceleration. Therein we have the second law of motion is also a vector law. Why? Because it is ultimately related to force. So, and we know this thing that force is a vector quantity, so second law of motion is also a vector law. So it is equivalent to three equations we can write down. If you have the three mutually perpendicular axes wherein the forces are acting, and one for each component of the vectors can be represented like this way, that is fx is given by dpx upon dt, that is equal to max. Similarly, for Fy and Fz, you have MAY and MAZ. Two examples are written over here. That is, it is easier for the strong adult to push a full stopping cart than it is for a baby to push the same cart. So ultimately, this is depending on the net force which is acting on the object. Also, it is easier for a person to push an empty shopping cart than a full one. Why? Because ultimately, this is creating. Ultimately, it is depending on the mass of the object. Now, Newton's third law of motion, wherein we will be looking forward to the every action there is equal and opposite reaction, and both acts on different bodies. Now mathematically, if we want to write down this law, then it can be written as force acting on force acting on second body due to first body is equal to force acting on first body due to the second body, but the sign is reversed. Okay, this negative sign only indicates the direction change. Okay, so examples are given as swimming becomes possible only because of Newton's third law of motion. Also, jumping of a man from a boat onto the bank of a river is possible due to it, and pulling of a cart by a horse, etc. These are few of the examples which we can take into account for Newton's third law of motion. Now it is important to note over here that Newton's second law of motion is also called as a real law of motion. Why? Because first and third laws can be obtained from it. So second law is of prime importance because of this particular reason, that first and third law can be obtained from it. Now we also take a note at the Lami's theorem, wherein it states that if three forces are acting on a particle are in equilibrium, then each force is proportional to the sine of angle between other two forces. Now make sure these forces are concurrent in nature. Now what is concurrent? What is concurrent nature? That is, it emerges out from the same point. Okay, as you can find this thing, that all the three forces are emerging out from the same point O. And let's say force 1 is acting towards this x-axis. Okay, this force 2 is acting at certain this direction. Force 3 is acting at certain this direction, and they tend to make the angles as mentioned over here, that angle between force 1 and force 2, that is given as alpha gamma. Angle between force 2 and force 3 is given as alpha, and angle between f1 and f3 is given by beta. So we can write it as f1 upon sine of angle between f2 and f3. See, when we are taking into account f1, then the angle which falls into picture, that is the angle between the other two forces, that is F2 and F3, which is alpha. Hence I am writing it as F1 upon sine alpha. In a similar manner, if I take into account this force F2, then F2 is equal to angle between sine of angle between the other two forces, that is F3 and F1, which is the angle named as beta. So I'm writing it as F2 upon sine beta. And lastly, we have F3 upon sine gamma in a similar way. And this is how Lami's theorem can be applied to many of the numericals wherein the concurrent forces we can observe like this way. Okay, so the forces must be concurrent in nature to apply the Lami's theorem. This is the prime part of this theorem. And we can utilize this formula to find out the forces or the angle traced between them. Now, next part which we will be looking forward to for the discussion, that is the concept of friction. Now, a force which is acting on the point of contact of the objects which opposes the relative motion is called as friction, and often it acts parallel to the contact surfaces. Frictional forces are generally produced due to the intermolecular interactions acting between the molecules of the bodies in contact. This is the fundamental part of friction. Now, when it comes to the category wise the division of friction, then it can be categorized into three different parts, that is static friction, limiting friction, and then after we have kinetic friction. So once we discuss the static friction is nothing but it is an opposing force which comes into play when one body tends to move over the surface of the other body, but actual motion is not taking place. Okay, that means the body is just tending to move, but it is not moving. It is just on the verge of starting to take its state of rest to state of motion. Okay, so this is the part wherein the static friction is coming into picture. So static friction is a self-adjusting force which increases as the applied force is increased. And also it is noteworthy to find over here that is static friction opposes impending motion. Then after the second type of friction which we'll be looking forward to, that is the limiting friction. Now, what is limiting friction? It is the maximum value of static friction when body is at the verge of starting the motion. Okay, so once it has reached that particular point of maximum value, then that particular point is known as limiting friction, limiting friction, which is denoted as Fs maximum. That is given as mu. Mu is the coefficient of static friction, mu L into R. Okay, mu is also known as coefficient of static friction, but since we are dealing with limiting friction, so I will abbreviate it with mu L. Okay, so mu L is equal to coefficient of limiting friction and R is equal to normal reaction. Now, limiting friction do not depend on area of contact of surfaces, but depends on their nature, that is whether the contact surface is smooth or rough. So it depends ultimately on that particular parameter. So this is the pictorial representation wherein the F and Fs are represented. So F is the force applied and Fs maximum is the limiting force of friction, wherein the body just is on the verge of motion. Now, when we talk about angle of friction and angle of repose, it is to be noted that it is the angle which is traced between the resultant of the force of limiting friction and the normal reaction. So the force of friction and normal reaction, the angle which is traced between it, that is known as angle of friction, wherein the coefficient of friction mu is equal to tan of angle theta. Now, let's say if the force is applied in this direction and the normal reaction is applied in this direction, let's say, okay, so the angle traced between the force it is the angle which is the resultant of the force of limiting friction. So if the resultant force is towards this way, okay, so angle between force and normal reaction, just a minute, let me trace it over here. So this is the normal reaction, this is the resultant force, and this is the angle of friction. Okay, if the body is along the inclined plane. So this is the case which we observe for the angle of friction. Now, angle of repose or angle of sliding. So it is the minimum angle of inclination of a plane with the horizontal such that a body is placed on it just begins to slide down. So after that, angle, after that particular angle value, the body will slide down. So it is the angle, it is the minimum angle of inclination of a plane with the horizontal, that such that a body placed on it just begins to slide down. So let's say if a body is placed like this way, and this is the alpha angle or angle of repose. So after this angle, the body will slide down. So this is known as the angle of repose or angle of sliding. Now, if angle of repose is denoted by alpha, the coefficient of limited friction is mu L, and we denote it as mu L is equal to 10 alpha. So these two equations are of prime importance in the MCQ type of questions. Then after the kinetic friction, so kinetic friction is ultimately an opposing force that comes into existence when one object is actually moving over the other object. So when two objects are in motion at that point of time, the kinetic friction comes into picture. Now, as it already can be observed from the word kinetic. Now see, whenever we discuss the fundamentals of mechanics, mechanics is ultimately divided into two different branches, that is statics and dynamics. In dynamics also we look forward the further explanation, we further category, that is the kinetics and kinematics. Okay, so at present the kinetic friction which we are dealing with, that is ultimately dealing with the dynamics part, and dynamics comes into picture whenever a body is in motion. So whenever we use kinetic part, it ultimately indicates that the bodies are in motion or moving body. So mu k, that is the coefficient of kinetic friction which we are representing, and r is the normal reaction to it. So equation which we'll be utilizing, that is kinetic friction Fk, okay, F subscript k, that is equal to mu k into r. This is the equation which we'll be utilizing for numerical problems. And kinetic friction is of two types, that is either a body can slide, so it experiences sliding friction, and if a body is rolling, then it experiences the rolling friction. Now it is noteworthy to find over here that rolling friction is less than sliding friction, therefore it is easier to roll a body than to slide it. Then after motion on a rough inclined plane, now this free body diagram can be easily observed for this particular fundamental, that is when an object moves along the inclined plane, and then different forces act on it like normal reaction of a plane, as you can find right over here. This is given by r. Then after the friction force along it in opposite direction of motion. So let's say if a body is tending to slide like at this position, so friction force is acting right over here in the direction which is opposite to the motion of slide. And we have the relation for this particular as r is equal to mg cos theta, where this mg is the weight of the block. Now weight of the block is acting always in downward direction, but since it is at a certain inclination, so the angle which we find over here, that is made by this normal the weight force and this line of this particular r line of action which is extended backwards, that is mg cos theta. So we find the normal reaction of a plane as r is equal to mg cos theta, and this net force which is acting downward on the block is given as F is equal to mg sin theta minus r. So this force ultimately, see, this is having two components. This weight is also a force, we know it has two components since this is the angle traced theta by this particular. So we know this thing from the fundamental of trigonometry, that the cosine component is the component which we find generally between the resultant and the adjacent part, or the hypotenuse and the adjacent part. So that is ultimately the cosine component which is getting associated like this way, mg cos theta. And the opposite side is generally we denote it with the help of sine component, so we write it as mg sin theta. So mg sin theta is experienced right this way, and mg cos theta is experienced the perpendicular to the mg sin theta. Okay, mg cos theta is perpendicular to the mg sin theta in this particular geometry of the figure. So ultimately the net force, if we try to count the net force, the net force can be counted on a very easy manner. That is, if we take the motion of advancement of the block as positive, so mg sin theta is positive, and friction, since it is resisting the motion of the block, so it is negative because it is towards the opposite direction of mg sine theta. Hence this capital F, it indicates that the net force acting downward on the block is given by mg sine theta minus F. Then after acceleration on inclined plane, which is given as a, small a is equal to g into bracket sine theta minus mu cos theta, when angle of inclination of the plane from horizontal is less than the angle of repose. So that means if the angle of inclination of the plane from horizontal is less than the angle of repose, that means theta is less than alpha. Alpha is the limiting angle of friction, or alpha is the angle of repose. And for this, minimum force required to move the body up the inclined plane, that is given by F1 is equal to mg sine theta plus mu cos theta. Whereas if the for the minimum force required to push the body down the inclined plane is given as mg mu cos theta minus sine theta. Okay, so this F1 is for moving the body upwards towards the inclined plane, and this F2 force is experienced, or we can find out this F2 force for minimum force required to push the body down the inclined plane. So that is given as mg mu cos theta minus sine theta. Now, motion of bodies in contact, it is also important to know over here that two bodies are in contact. If force F is applied on an object of mass m1, then acceleration of the bodies is given as A equals F upon the sum of masses of the boxes or blocks or bodies, and contact force on body of mass m1, that is given as force is equal to mass into acceleration. So mass is m1 into acceleration, that is F upon m1 plus m2. So ultimately contact force on m1 is given as m1 into F upon m1 plus m2. And on a similar way, contact force on m2, that is contact force on body of mass m2, that is over here. So it is given as m2a upon, it is given as m2a, that is equal to m2f upon m1 plus m2. Then after, if three bodies are in contact, then the relation turns out to be acceleration of the bodies is given as A equals F upon m1 plus m2 plus m3, that is the sum of masses of the all the three bodies. And for contact force between m1 and m2, if we take only these two particular bodies, for that the contact force is given as the sum of the blocks of two bodies, that is m2 and m3. We take these two sum total, and it is divided by sum of all the bodies, and it is to be taken in product with F. And similarly for contact force between m2 and m3, that means the last two bodies if we take into account, for that we have only m3 over here in the numerator, and thereafter we have m1 plus m2 plus m3 in the denominator, and this F is in the product. Okay, so this is the part which we will be looking forward to as and when the motion of bodies in contact is to be considered. Now let's try to simplify a few of the problems based on the laws of motion. Now these are very basic problems for the simplification part. Now the first question is given as inertia of body is measured with the help of which physical quantity. So we are having the four options as mass, force, momentum and acceleration. So the answer is very easy. Inertia is dealing with ultimately which part? So inertia of a body is measured with the help of which physical quantity? It is very easy to answer if you recall the fundamental of Newton's first law of motion. So yes, definitely I can find many of the responses in the chat window. And yes, mass certainly is the correct answer to it. Okay, inertia is the property, as we have already known this thing from the Newton's first law of motion, that is more the mass of the object, more is the inertia. Keep this thing in mind, more is the mass of the object, more is the inertia, less is the mass of the object, less is the inertia. This is the thing which you need to keep in mind for the answering of this question. Next question. Now it is given as a block of mass 1500 grams is is moving with speed of 30 meter per second. 12 Newton force is acting in the direction of motion and 5 Newton force is acting in the perpendicular direction for 3 seconds. Now the speed of block after 3 seconds is how much meter per second? Now to simplify this question, the task you need to do is very easy. Let me simplify this problem right over here. Now see, mass is given in grams, but since we know that mass is to be taken in SI units, so we need to write it as mass is equal to 1.5 kg. Now these simplification steps I am elaborating just for the sake of better understanding. Whenever you are simplifying any MCQ, no need to go into so detailed manner. You can directly calculate the final results. Okay, so mass is 1.5 kg. The initial velocity, see, since it is already moving it, so u is given as 30 meter per second. Then 12 Newton force is acting in the direction of motion of the block, and 5 Newton force is acting in the perpendicular direction. So can we take the components of force as Fx is equal to 12 Newton, Fy is equal to 5 Newton. Now to find the resultant of these two forces, we use the formula generally for resultant. Let's say resultant force is Fr. So Fr is equal to under root of Fx square, okay, plus Fy square, that is equal to under root of 12 square plus 5 square, that is equal to under root of 169. That gives you the answer as 13 newtons. And we find that the forces are acting for a duration of 3 seconds. So time is given to you. Now which formula you will be utilizing it for this particular question? The formula is very easy. We use the formula as F is equal to ma. Okay, so we have the F as Fr, that is the resultant force, and this acceleration can be written as v minus u upon t. So we use these terms over here. Fr is equal to 13, mass is 1.5, and v, that is the final velocity we are intended to find. So I will keep it as it is. Initial velocity is 30, and time duration for this particular is 3 seconds. So I will write 3 over here. So if you have the simplification of this, it is 13 into 3 equals 1.5 v minus, it is 45. Now if you bring down the simplification properly, that is 13 into 3, that is 39, equals 1.5 v, and this minus 45 goes to the left hand side and turns out to be plus 45. So I'm writing it 39 plus 45. All right, now can you simplify this further? It is very easy. 39 plus 45, that gives you the answer as 84. So you need to take the division of 84 with 1.5. I'm erasing these annotations because I need to do further simplification steps over here. So V is equal to ultimately 84 upon 1.5, and that gives you the answer as, what will be the answer? Please have it in chat window. Very good, very good. Yes, definitely the answer is 56. If you simplify it, the answer is 56 meter per second. So there you are done with your simplification of this problem. Now let's proceed ahead with the problem number 3, that is given as a machine gun fires 20 bullets per second into a target, and each bullet weighs 150 grams and has a speed of 800 meter per second. We need to find the force necessary to hold the gun in position. So the options are given as 800, 1000, 1200 and 2400 newtons respectively. Now the simplification steps are very easy. What you need to look out, that is the first of all, the total mass of the bullets which are fired per second, that is taken as mass per second. I'm writing it as just a minute, mass per second, that is equal to, see, this 150 is getting multiplied by 20. So I'm directly writing it as 3000 grams per second, that is equal to 3 kg per second. All right, now velocity of the bullet, that is 800 meter per second. So this is the final velocity. Initial velocity, since it is already inside the gun, so it is 0. U is equal to 0. Now once again we use the same formula over here, and since it is firing per second, so I will take time duration as 1 second. Okay, so t is equal to 1 second, so we can write the formula as F is equal to m v minus u upon t. So you can substitute all these values, that is 3 into 800 minus 0, I'm writing it as 800 itself, and t is 1 second, so our answer turns out to be very good, very good. Yes, it is 2400 newtons. Let's proceed further. Now it is given as a block of mass m is pulled along a horizontal frictionless surface by a rope of mass m. So if force P is applied at the free end of the rope, the force exerted by the rope on the block will be how much? So in this case, we need to find the force exerted by the rope on the block. Okay, so for that, let us try to pictorize the given system. So this is the surface, and this is the block over here, and let's say it is attached to a certain rope. Okay, this is the block and this is the rope. The mass of the block is capital M, mass of the rope is small m. Now acceleration of this entire system, that is given as A is equal to the pull force which is exerted by over here with the help of this rope, that is P, okay, upon sum of the masses, that is capital M plus small m. Now force acting on rope of block of mass capital M, that is given as F is equal to MA. Now A value we have it as P upon capital M plus small m. So that brings down to the answer as which one from the given option? See, this M is capital over here. So what will be the correct answer? A is P upon capital M plus small m. Very good. So this certainly brings to the result as option C, that is P into capital M upon sum of the masses. All right. Moving ahead with the next problem. If a ladder weighing 250 newtons is placed against a smooth vertical wall having coefficient of friction between it and floor as 3.3, then what is the maximum force of friction available at the point of contact between the ladder and floor? Now this is very easy problem. It can be solved without any calculation. Simply you observe the values, take the values into product, and there you go with your answer. So simply multiply 250 and 0.3 and you obtain your answer. What is it? You can have the answer in the chat window. Very good, very good. So yes, that brings down to the answer as 75 newtons. Okay. Now students, let us try to move ahead with the next particular fundamental, that is the fundamental dealing with work, energy and power. Now the fundamental of work, that is, what is work? When a force acts on an object such that it displaces through some distance in the direction of applied force, then the work is said to be done. The formula which we generally utilize for finding out the work done, that is, work done is given as W is equal to F dot S, that is Fs cos theta. And it is important to note that work is a scalar quantity. Okay, why? Because if we take the dot product of two vectors, see, this force is also a vector quantity, displacement is also a vector quantity. So if both vectors are taken as dot product, we generally obtain it as a scalar. This you already know from the fundamentals of vectors. So its SI unit is joule and CGS unit is erg. So 1 joule is equal to 10 raised to 7 erg. This is the thing which you need to keep in mind. And its dimensional formula is given as ml2t minus 2. Now proceeding ahead with the next part, that is the work done by a force is zero if either the body is not actually displaced, that is the displacement is zero. Let's say if you are trying to push a wall, okay, so you are utilizing your energy but your work is not done. Why? Because wall is fixed, okay, wall is stationary object and you are trying to push that stationary object, so ultimately work done is zero since the displacement is zero. And body is displaced perpendicular to the direction of force, at that point of time also work is not done, okay, or work done by the force is zero. So work done by a force is considered as positive if angle between force and displacement is acute angle, that is it is less than 90, and work done by a force is negative if the angle between force and displacement is obtuse angle. Okay. Now work done by a constant force depends only on the initial and final positions of the object and not on the actual path which is followed between initial and final positions. Now, the few noteworthy points dealing with the work done in different conditions, that is work done by a variable force is taken as the integral of dot product of force and displacement. That is work done is equal to F dot integral of F dot ds. So it is equal to the area under this force displacement graph, which you can find over here along with the proper sign to be taken into consideration. Also, work done in displacing any body under the action of a number of forces is equal to the work done by the resultant force. Now, in equilibrium condition, whether it is static or dynamic, the resultant force is always zero. Therefore, resultant work done is also zero. And one more noteworthy point over here, that is work done by the force of gravity on a particle of mass m is given by W is equal to mgh. Okay, wherein g is the gravitational acceleration or acceleration due to gravity, h is the height through which the particle is displaced. Thereafter, work done in compressing or stretching of a spring is given by work is equal to negative of half kx square, where k is the spring constant value and x is the displacement from the mean position. So when one end of a spring is attached to a fixed vertical support and the block is attached to the free end, which it moves on a horizontal table from any initial position x1 to final position x2, then we can take the work done for this particular example, that is given as 1 by 2 into bracket k into bracket x2 square minus x1 square, that is the difference of the square of the difference of the positions. Okay. Now work done by the couple for an angular displacement theta is given by W is equal to tau dot with theta, wherein tau is the torque of the couple. So these are few things which you need to keep in mind. Then after the fundamentals of energy, now I will pace up my presentation since we need to cover up two more topics. Now energy of a body is the capacity to do work. SI unit is joule, CGS unit is erg, and dimensional formula is mL2 T minus 2. Mechanical energy, it is sum of kinetic and potential energy. Now kinetic energy, that is given by half mp square. This basics, you already know this thing. It is the energy possessed by any object by virtue of its motion. Whereas the potential energy, it is the energy possessed by the object by virtue of its position or configuration, which is given as f of x is equal to minus du by dx. Okay, so potential energy is defined only for conservative forces. Now this thing you need to keep in mind for MCQ aspect. Potential energy is defined only for conservative forces. It does not exist for non-conservative forces. Okay. Also, it depends upon frame of reference. So if frame of reference is getting changed, then the potential energy will differ. Then after the three important types of potential energies, that is GPE or gravitational potential energy, EPE or elastic potential energy, and once again EP, that is electric potential energy. Now potential energy which is due to gravitational acceleration, that is given as mgh. When it comes to a spring, then we have the potential energies which is energy stored in the spring is given as half into kx square, and electric potential energy is given as 1 upon 4 pi epsilon 0, wherein we also write it as k, small k, we already write this thing, and it is into the product with q1 q2 upon r. Okay. Now work energy theorem is the prime part, that is work done by a force in displacing a body, it is equal to change in its kinetic energy ultimately, that is we take the difference of the initial and final states kinetic energy. So if W net is positive, then Kf minus Ki is positive. that is kf is greater than ki, that is final kinetic energy is greater than initial kinetic energy, and or kinetic energy will increase, and reverse is the case if w net is negative. So this theorem can be applied to non-inertial frames also. Okay, and non-inertial frame can be it can be written as work done by all the forces including the pseudo force which we take into account, that is equal to change in kinetic energy in non-inertial frame. Now for the fundamental of power, the fundamentals are very easy, that is rate of doing work is known as power, that is work done upon unit time. Now work done, that is given as force into displacement, we take the dot product of force and displacement divided by time, but we know that uh, displacement upon time is velocity, so we also rewrite this equation of power as dot product of force and velocity, wherein p is equal to fv cos theta can also be written. Okay, wherein theta is the smaller angle between force and velocity. Now power is a scalar quantity once again, since it is the dot product of two vectors, and SI unit is watt, and its dimensional formula is ml2 t minus 3. Other units of power are kilowatt and horsepower. So 1 kilowatt is equal to 1000 watts, and 1 horsepower is equal to 746 watt. Now this particular is most of the times it is asked in the competitive examinations. So this thing you need to keep in mind, what is 1 horsepower equal to. Okay, though it is remembered, but still as a kind of revision you need to keep this value in mind. Now 1 kWh kilowatt hour, that is equal to 3.6 into 10 raised to 6 joules. Now let's try to simplify one problem based on work, energy and power, that is given as two students kept their bag on a table at a height of 1 meters. Mass of their bag are equal, and time to keep on a table for student 1 is 3 times than student 2. The ratio of work done by them is how much? The ratios are given as 1 is to 3, 3 is to 1, 9 is to 1, and 1 is to 1. Now see, both the students are doing work, that is they are keeping their bag on the table, that means they are lifting the bag and keeping it on a table. That means the fundamental of potential energy comes into picture. Now potential energy is not having time period in its equation, so based on it also a very common fundamental can be applied, that since it is not having any time duration involved in the equation, we can directly come up to the conclusion of this particular example as option D. Okay, so 1 is to 1 is the work done. All right, next problem dealing with this particular part. Now two balls A and B freely falls from the same height. Okay, two balls A and B freely fall from the same height. Ratio of their mass are 1 is to 4. When potential energy of A is 3 times the potential energy of B, we need to find the ratio of distance traveled by them. So the simplification steps are very easy. First, let me display the options. All right, now we'll try to simplify the problem quickly. Now see, the ratio are to be taken as ball A is to ball B. So I'm abbreviating it as A is to B. Okay. Now we use the fundamental of potential energy, that is U1 upon U2, that is equal to, now since G is constant and it can be eliminated when we take the ratio, I will directly write the ratio as M1 H1 upon M2 H2, and we need to find H1 upon H2. So you have the values of potential energy as, see, it is given as potential energy of A is 3 times the potential energy of B. So U1 equals 3 U2, which implies U1 upon U2 equals 3. And M1 upon M2 is given as 1 upon 4. So I will rewrite this particular equation as U1 by U2 is replaced by 3 equals M1 by M2 is replaced as 1 by 4 into the product with H1 upon H2. So H1 upon H2, that gives you the answer of ratio as 4 into 3, that is equal to 12 upon 1. So it is 12 is to 1. And yes, there I can find the answer is already displayed in the chat box. All right, moving ahead with the simplification of next problem. Problem 3. When a rail of mass 12 into 10 raised to 6 kilograms is pulled by an engine, its velocity increases from 3 meter per second to 5 meter per second in 2 minutes. What is the power of engine? This we need to find. Your options are displayed as 200, 400, 600, and 800 kilowatts. Now see, time duration for this particular is 2 minutes. So I will write it as 120 seconds. Okay, we are having the velocities as v is given as 5 meter per second. So v is equal to 5 meter per second, and u is equal to 3 meter per second. So the acceleration for this particular turns out to be a is equal to v minus u upon t, which gives you the answer as 2 upon 120. 5 minus 3, that is 2. 2 upon 120, that is equal to 1 upon 60 meter per second square. Now we need to find out the displacement. Why? Because we need to find the power of engine. Okay, and we know this thing pretty well, that power, that is equal to force times displacement upon time. Okay, this is the equation which we are utilizing it. So we need to find out the displacement. So displacement can be found out using the formula for the equations, from the equations of motion, which you already know this thing, that is v square minus u square equals 2as. Okay, three equations of motion, you need to recall it. So v square minus u square is equal to 2as. You are having the value of v, u, and a. Substitute it and you find the value of s. So v value is 5. So it is 25 minus 3 square, that is 9. That is equal to 2 into the product 1 upon 60 into s. So that gives you the value of s after simplification as 480 meters. I'm directly writing the value right over here. Now you have the displacement with you. Okay, you have the mass with you. You need to utilize these particular parameters in this equation. Now force is equal to mass times acceleration, so I will write the equation of power as m into a into s upon t. We have all these values, so I will substitute it directly. 12 into 10 raised to 6 into acceleration, which we have already found it as 1 by 60, into this displacement value, which is 480, and it is whole divided, by time duration, that is 120 seconds. If you take the simplification, it will result into the value as, yes, very good, I can find the responses in the chat, that is option D, 800 kilowatts. Alright, so just you need to figure out that what equation is to be utilized, and based on that equation you need to look out the parameters, that are you having the values of parameters. If yes, then directly substitute it. If you're not having the parameter values, then some of the other details will be provided to you, wherein you need to utilize those details in finding out the given parameters of the equation, and then after you can substitute those values and find your answer to the given question. So answer is 800 kilowatts. Now let's study quickly the laws of gravitation, wherein Newton's law of gravitation is stated as the gravitational force which is acting between two point objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So gravitational force F is equal to G m1 m2 upon r square, wherein G is a universal gravitational constant. Its value is given as 6.67 into 10 raised to minus 11 Newton meter square per kilogram square, wherein the dimensional formula of G, that is given as m raised to minus 1, L raised to 3, T raised to minus 2. The important points which you need to take care of for this gravitational force, that is, it is a central as well as conservative force in nature. It is the weakest force which you observe, and it is 10 raised to 36 times smaller than the electrostatic force and 10 raised to 38 times smaller than the nuclear force. Now these values are of utmost importance when it comes to the MCQ type questions. Okay, you will be directly provided with these values in the options, and you need to figure it out that which value will be the right choice for your given question. Thereafter, the law of gravitation is applicable for all bodies irrespective of their size, shape and position. Then gravitational force which is acting between the sun and planet provided centripetal force for the orbital motion. And lastly, Newton's law, third law of motion, holds good for the force of gravitation, which means that gravitational forces between two bodies are action and reaction pairs. So these are noteworthy points related to the gravitational force. Now the GPE, or the gravitational potential energy, which is given as U is equal to minus G, the product of the capital M and small m upon R, wherein M and M are the masses of two different objects, okay, or two different bodies, and R is the distance between them. So the negative sign shows that the gravitational potential energy decreases with increase in distance. So as the distance increases, the GPE decreases. Okay. Now, few of the cases, these cases will readily help you out in the simplification. That is, potential due to a point mass is given as, suppose a point mass M, which is mentioned over here, point mass M is situated at a point O, and the gravitational potential due to this mass at a point P is given as V is equal to minus G M upon R. Okay, since only one M is there, we will write only M over here. And potential due to a uniform ring, that is given as, if you are intended to find the potential at a point on its axis, then it is given as minus gm upon under root of a square plus r square, wherein a is the radius and r is the distance of the point mass and the center point of the ring. Okay, and if you are intended to find at the center, then it is given by minus gm upon a. Then after, potential due to a spherical shell, that is given for three different cases, as first is for outside the surface, wherein the r value, that is the distance from that point to the axis, is given as minus gm upon r. And if r is equal to r, that is it is on the surface, so it can be written as v is equal to minus gm upon r. And if it is inside the surface, we write it as minus gm upon r. Now, potential due to a uniform solid sphere, that also can be figured out in a similar manner. Then we come across the Kepler's laws of planetary motion. Now, we will study few laws related to the Kepler, that is law of orbit, which states that every planet revolves around the sun in an elliptical orbit and sun is at one of its focus. Okay. Now, this A is ultimately the half portion of the major axis, and this S is the location of the sun. It is one of the focus of ellipse. Then after the law of area, it states that the radius vector drawn from the sun to a planet sweeps out equal areas in equal intervals of time, wherein area velocity of a planet is given by dA by dt is equal to L upon 2m, it is equal to constant. And lastly, law of period, that is the square of the time period of the revolution of a planet around the sun is directly proportional to the cube of the semi-major axis of its elliptical orbit. So t square is directly proportional to a cube. If we try to put down into the relation part properly, then we need to remove this constant of proportionality, that is given as t1 by t2 the whole square equal to a1 by a2 the whole cube. Okay, wherein a is the semi-major axis of the elliptical orbit. Now let's try to simplify a few problems based on this gravitation part. So problem 1 is given as three uniform spheres, each having mass m and radius r, are kept in such a way that each touches the other two. The magnitude of the gravitational force on any sphere due to the other two is given as what? So we need to identify this particular situation in a manner wherein the three spheres are placed like this way. Okay, and these are the center point of the spheres. If you try to connect it, since these spheres are of equal measures, okay, they will form an equilateral triangle when they are placed like this way. And if we try to join the hypothetical line from their centers, okay, so they will form an equilateral triangle. So if you notice over here, then I need to draw the force diagram right like this way. Let's say this is A, this is B, this is C. Let's say this is FA, FB, and the angle between the two sides of equilateral triangle is 60 degree. We already know this thing. All right. So if we are intended to find the resultant of FA and FB, okay, the resultant force will be like this way. So that is given as RF or FR, whatsoever the notation you use. Resultant force FR is equal to square root of F square plus F square plus 2F into F into cosine of angle between the two forces, that is cosine 60 degree. Now if you simplify it, it turns out to be F square plus F square plus 2 into F square, and cos 60 is 1 by 2, and if you re-simplify it, it is under root of 3F square. So root 3F is the answer. Resultant force is root 3F. Okay. So now we have the force which is acting between the other two spheres. The magnitude of gravitational force on any sphere due to the other two spheres is given as Fr is equal to, I will directly write this value. Okay. It is since the body are of equal masses, so I can write it as gm square upon, now the radius is of r measure. Okay, the radius is of r measure, so we have the entire length of this one side it as 2r. Okay, so r plus r is 2r, so I'm writing it as 2r the whole square. So that ultimately turns out the equation, turns out the result as gm square upon 4r square. And if I want to utilize this result over here, so it is root 3 gm square upon 4r square, which brings us down to this answer as option D. All right. Thereafter, next problem. Now see, the Mercury, which is a planet, is revolving around the sun as shown in figure in the elliptical path. The potential energy of the Mercury will be minimum at which point? Now it is a very conceptual question. See, wherever the kinetic energy of the planet will be maximum, the potential energy will be minimum. So the kinetic energy for the Kepler's laws of motion, if you have studied it thoroughly, it is maximum at this particular point wherein the sun is at this particular focus. So at this point S, the kinetic energy is maximum, so the potential energy of the planet is minimum. Okay, so this is the key conceptual part which we are utilizing it over here, and hence it brings down the answer as option D, S. Now let's try to observe the result for fluid pressure and capillarity, the last part of our today's session. So fluid pressure and capillarity, the fundamental states that pressure is equal to force upon area, wherein it is given in pascals. So 1 pascal is equal to 1 Newton per meter square. But since pascal is a very small unit of pressure, we generally denote it with a higher unit, that is either we denote it with ATM, that is atmospheric pressure, or with a bar. Okay, so 1 bar is equal to 10 raised to 5 pascals. If the pressure is to be measured in vacuum, then we use the unit as torr. So 1 torr is equal to 133.28 pascals, which is also equal to 1 millimeter of Hg, that is mercury. So 1 atm is equal to 760 is 76 centimeter of mercury, that is equal to 760 mm of mercury. Now thrust on the liquid, that is equal to the total force acting on the liquid surface of the liquid by the liquid is called as the thrust of the liquid. Then after, the pressure due to the fluid column is given as P minus PA, that is PA is the atmospheric pressure, and that is equal to H rho G. Okay, so this is the gauge pressure which we calculate. So ultimately total pressure is equal to atmospheric pressure plus gauge pressure. This is the fundamental part. Now when it comes to the capillarity, so capillarity is the phenomenon of rise or fall of a liquid in a capillary held vertically in a liquid column. So angle of contact, okay, so this theta angle which you can find right over here, okay, this theta angle, if it is less than 90, the meniscus is concave, that is the water wets the surface, so water rise in capillary. And if the angle of contact is greater than 90 degree, it is obtuse angle, so you can find the case right over here. So it is a kind of non-wetting fluid which is undergoing this particular phenomenon. and the meniscus observed in this case is convex in nature. Okay, so the liquid falls in the capillary due to the non-wetting phenomenon. Now the equation of height, which is many times utilized in the calculation of various examples based on this capillarity, that is given as 2t upon r is equal to h rho g. Okay, but cos theta is equal to small r upon capital R. Now the values of small r and capital R you can observe right over here. Okay, that is, this particular values are given as r is the small r is the radius of capillary and capital R is the radius of meniscus. Then the surface tension is given as capital T, H is the height of the liquid column, rho is the density of the liquid, and theta is the angle of contact. This formula is primarily utilized in the calculation of height of the liquid. Okay, height of the liquid column. So when theta is less than 90, H is positive, so liquid will rise up, and if H is negative, liquid will fall down. So H is ultimately inversely proportional to R. From this we can conclude that height of liquid column is inversely proportional to the radius of capillary. Also, for any two coaxial tubes of radiuses R1 and R2, okay, wherein inner tube is solid, so H is given as 2T upon R2 minus R1, that is the difference of the radii, product with density of the liquid and gravitational acceleration. Now let's try to observe two problems based on this particular portion. Problem 1, a cubical tank is completely filled with water, is fixed on a trolley, and if this tank is accelerated with A, then pressure at which point is maximum and pressure at which point is minimum. So when the acceleration is towards the right hand side direction, then the liquid which is filled inside this trolley, it turns out to be, like this way. Okay, since the inertia of will come into role play, so the maximum pressure will be exerted on this particular point, that is located right over here, and the minimum pressure will be exerted at this particular R point. This is a very common understanding kind of question which is asked in this particular case. So the answer turns out to be option A, that is Q and R. The last question pertaining to this: when an air bubble rises from bottom of a lake to the surface of a lake, its volume increases by 4 times. Now, if 75 centimeter of mercury column producer atmosphere depth of a lake is watt meters, density of water is given to be 1/10 of that of mercury. Now, in this case, how to simplify these kind of problems? But before, let us try to simplify this right over here. So we need to take certain assumptions in this simplification. That is, let us assume that the process which is happening over here is isothermal in nature. Now, what is isothermal process? PV is equal to C. Okay, so pressure P1 V1, or let us say PS Vs is equal to PD Vd. Since temperature is remaining constant, so we will assume the process to be isothermal in nature. S and D are the notations utilized for surface of water, and D denotes the depth of water. Okay, so at uh, two different levels we obtained two different pressures. So we abbreviate it as either for S we abbreviate it as for the surface, and D we abbreviate it as for the depth. So PSVS is equal to PDVD. Now we know that from this particular concept which is provided, that its volume increases by 4 times. So we know that Vs is equal to 4 times Vd. Okay, so when an air bubble rises from a bottom to the surface, so let's say if the lake is assumed to be like this way, okay, and the bubble from the bottom, it rises to the surface, so the volume becomes 4 times. So for that, Vs is equal to 4 Vd is the relation according to this condition which is provided to us. Then after, the particular portion which is provided as 75 centimeter of column mercury, so that is given as PS is equal to 75 centimeter of He, that is mercury, and pressure at the depth of the lake, that is given as, see, this surface pressure is already dominating, along with it the 1/10 of the mercury. This part also we need to consider, so I will write it as 75 plus H upon 10. So this H value can be calculated now readily. You need to have a simple substitution. Okay, so this value I will rewrite it as 75 into 4 is equal to 75 plus H upon 10. All right, then we'll try to simplify it further. So 75 into 4, that gives you the answer as 300 is equal to 75 plus H upon 10. And if you do the further simplification, you will come up with the answer. It is 225 is equal to H upon 10. So H is equal to 2250 centimeter. Now since it is centimeter, and the answer is in meters, so divide it by 100, and there you go with your answer as 22.5 meter. Yes, very good. So on this note, I would hereby like to conclude our today's presentation based on the mechanics portion. I'm once again really thankful to the Admizz team for providing me this wonderful opportunity to take the COMPEX classes. And tomorrow we will be conducting session on the next topic, that is heat. So thank you so much, Admizz team and students, for attending our session.